Okay, so in this particular case, we've got a hydrated sample of MgCl₂, and you've been told what the mass was when it's hydrated, as well as what the mass becomes once the water's been removed. And we need to use the information to figure out, well, what's the coefficient that's going to be next to the H2O here, right? Okay, so how are we actually going to go about working this out? Well, in this case, we need to be able to compare the moles of the MgCl₂ and the moles of the H2O. If we're able to compare that, we would be able to, based on the ratio, work out well what the coefficient is going to be. So let's go through that process. In order to figure out the moles, we do need to work out the some molar masses, right? So what I'm going to be doing first is I'm going to try and work out the number of moles of the MgCl₂ component, right? And in this particular mass is the hydrated mass. So this is the mass of the whole thing. So that's not necessarily going to be the most helpful initially. But this, which is the mass when the water is removed, is going to effectively be the mass of this component. So this is the mass I'm going to use to work out the number of moles of this. So for but I need to also work out the molar mass, right? So the equation would be that the mass is equal to the number of moles multiplied by the molar mass, right? And the number of moles, therefore, if you divide both sides by the molar mass, the number of moles is equal to the mass divided by the molar mass, mR, right? So we have the value of the mass, which is 2.84, and the molar mass, well, we can use the periodic table to work out what the molar mass is, right? So we're going to do that. So for MgCl₂, right? So we've got Mg here and Cl here, right? So I've just got them here as well for convenience. So that's going to be 24.3. So that's for the Mg side of things, plus the Cl₂ component. So that's going to be plus 35.5 multiplied by 2, right? And that's going to give us 95.3. Okay. Now, and that's going to be in grams per mole, right? So that's going to be 95.3. And so if you have a go at working this out, this is going to tell you the number of moles for the MgCl₂, right? So the number of moles of the MgCl₂ is going to be equal to that, and that's going to give us 0.029801, right? And yeah, this is just to 5 significant figures. Okay, so and that's going to be in moles as well. So you can just write moles. I mean, that would usually be afterward, but anyway, so that's in moles. We also need to work out the moles of the H2O, right? So, you know, I'm going to just quickly swap this around because it's much more preferable to say moles to a certain number of significant figures rather than saying significant figures to a number of moles. Sounds a bit strange to to say that, right? Okay, so that should kind of solve that. Okay, so yeah, so now we need to work out the number of moles for the H2O, right? Now we don't actually have a mass for the H2O, but we can arithmetically work out what the mass is going to be for the H2O. All we need to do is take the mass of the hydrated sample and subtract the mass of the dehydrated sample. So 4.46 minus 2.84, and this is going to give you the mass of the H2O, right? So if you do that, you get 1.62, and that's going to be in grams, right? And so this is the mass we're going to use in this same equation, right? So effectively, we would say that the number of moles in this case, so the number of moles of H2O is going to be equal to 1.62, and then we have to divide that by the molar mass of H2O. Now you may already know what the molar mass of H2O is. I mean, it's very common, it's a common number, but for the purpose of completeness, I'm going to work this out. That's going to be H, so here we've got H2O, so it's going to be effectively 1 times 2, so for the H2, plus for the O is going to be 16, right? And of course that's just simply 2 plus 16, which is going to be 18, right? And that's going to be in grams per mole. So that's the molar mass of H2O, right? MR of H2O equals. Okay, so with that in mind, this is going to give us the number of moles. So, and if you do have a go at working that out, you should find that gives you exactly 0.09, right? And that's going to be in moles. Okay, so we actually now have two values. We've got, and I'm going to keep the MgCl₂ on the left hand side just because of how it's formatted here, right? So just it makes it a bit more straightforward to follow. So establishing a ratio here, the number of moles of MgCl₂ as a ratio compared to the number of moles of H2O, okay? And that's going to effectively be this value, so 0.029,801 ratio to 0.09, okay? And what we need to do to progress what we're trying to actually figure out, we need to bear in mind the fact that the coefficient here in our the example what we're trying to solve for, we can infer that the coefficient here for MgCl₂ is 1, right? So obviously it's not written there, but the coefficient is 1, right? So what we want to do is try and get the number of moles on the left hand side, which correspond to the MgCl₂, to 1, right? And obviously the fastest way we can do that is divide it by itself, right? So we can divide that by 0.029,801. And now because this is a ratio, what we do to the left hand side, we also need to do to the right hand side. So we're going to also divide this side by the same thing. So 0.029,801, right? And if you work that out, of course, this side is you're going to get to 1. But then if you have a go on your calculator, work out what this what the right hand side is going to be, you should find that you get 3.02 and then 00, right? I mean, there would be a 3 here, but I'm just round it to like 5 significant figures. Okay. Now, the coefficient, as we know, for the H2O, it's gonna need to be an integer value, right? So this is gonna be an integer value. And so what we're gonna do is we're gonna round this value, right? And once we round it, effectively what we get is 1, 2, 3, okay? And so it's a 1-to-3 ratio, and based on that we can infer that the value of the x is 3. So we're going to put 3 here, right? So therefore MgCl₂ dot 3H2O, yep. MgCl₂ 3H2O. Okay,